Hey there, astronomy class. It's Miss Ewing. Looks like we'll be working together this semester for astronomy. We're just going to dive right into some of the basics, helping us navigate the night sky. So, some very, very simple basics. A star is basically a massive ball of gas capable of producing nuclear fusion, which is what allows it to emit light and heat. Compare that to a planet. That's one of the 8 major bodies rotating around our sun. We'll talk about exoplanets later. Circumpolar stars are those that basically rotate around the pole. They never go below the horizon, so they can be seen year round. Constellations are groups of stars that create an image in the night sky. And then, of course, the Milky Way is the galaxy which we belong to. So there's a couple of things, again, to use to navigate the night sky. The key one is Polaris, right? What we call the North Star. So that can help, especially navigating if you don't have the luxury of having something like a GPS available to you, or perhaps you can't get GPS signal. So just showing you some things as seen from Earth, right? So the horizon, I think most of us are familiar with that, is where, if it goes below the horizon, you can no longer see that. Doesn't mean there's nothing below that point. It's just from your perspective, you cannot see anything. And then here on the ends of the globe on either end, it shows you kind of where you would see those circumpolar stars. They never go below the horizon from that perspective. So if we do a time-lapse photo of the night sky, and of course these little stripes, if you will, represent stars, notice the one in the center that never appears to move. Any thoughts as to which that one might be? The rest of them are what we see as the circumpolar, right? So again, this is a time-lapse photo, and so over the course of time, they do orbit that central point. Since we know that stars rise in the east and set in the west, which way does the Earth rotate? And so a good way to describe that would be clockwise or counterclockwise. So let's look at some ways where we can describe, if we're trying to tell someone how to get somewhere, how we could do that. And a lot of times we start off by just using landmarks, come up this road going north. Once you see the Marathon gas station on the right, you want to go ahead and turn left at the stoplight. That's a lot of times how we give direction, using landmarks to describe a location. So, probably a more accurate way, or if someone's not familiar with an area, way of getting someone somewhere would be using a coordinate system. So it's a system using numbers and given a set location. And so we do that by using what's called latitude and longitude. So the coordinates are the numbers used in the coordinate system. And for each degree, that's a measure, unit of measure of an angle, right? And so since we're a globe, right, it makes 360 degrees. So latitude is the angular distance of a point north or south of the equator, or the 0 point. And the longitude is the angular distance east or west of the prime meridian, which is the 0 point. So the 0 point, again, for the coordinate system is the prime meridian is 0 for longitude, and the equator, of course, is 0 for latitude. Then we have a great circle, which is a circle that bisects a sphere. So it's basically used a lot for navigation. It's the quickest way to get from one point to another. So, what is the difference or the benefits between verbal descriptions versus a coordinate system? So the horizon system is a coordinate system using altitude and azimuth. So we're going to start applying this to the night sky, right? Altitude is the angular distance between the direction to an object and to the horizon. The azimuth is the angular distance between the north point on the horizon eastward. The celestial horizon is the boundary between the earth and the sky. And then the celestial sphere it's a made-up thing, right? It's an imaginary sphere surrounding Earth. So if you've ever seen like a three-dimensional globe of the sky and the constellations, that was a celestial sphere. So, zenith is the point on the celestial sphere directly above the observer. So, if I'm standing outside, the point directly above my head is the zenith. Okay. We measure, again, in degrees, which is the unit used to measure angles. And then if it's smaller than a degree, we have a 60th of a degree, which is a minute of arc. And then we can divide that even smaller into a 60th of a minute of arc, which is called a second. So, question to consider, how many seconds of arc are in 1 degree? So again, just showing you some of these things we've mentioned, especially the zenith. So if I'm in a raft in the middle of the ocean, the point directly above my head is the zenith, and it's 90 degrees then to the horizon. So let's say we're looking at a constellation such as Big Dipper, and I want to tell you where a particular star is, okay? I could tell you that it has an altitude of 30 degrees above the horizon. I could tell you that, again, from the starting point, the azimuth would be 330 degrees to that location. And so that's one way of describing it. We could look at Polaris. It's a little bit higher. Notice it has an altitude of 40 degrees. So again, this is just giving you reference points as to where things are, locating things in the night sky using these methods of location. So again, showing you these two things in real life. Notice the Big Dipper over here and the 30 degrees, right? And then, of course, the North Star, Polaris, at 40 degrees here.